So we're told that both of the common differences for these two series are prime numbers. So I'm going to assign them P1 is the common difference, and P just referring to the prime part. And same thing with the B1, B2 series. Let's call that P2. Now I'll apply those conditions here, starting with A sub 5 would be A1 plus 4 times the common difference. And then we're told that this is equal to B9, so that would be B1 plus 8 times P2. So that's our first relationship. Second one is A19 is equal to B19, so that would be A1 plus 18P1 is equal to B1 plus 18P2. So that's my second equation. And finally, B2 is 0. B2 is B1 plus P2. And that means B1 is minus P2. So I'll replace that with minus P2 here. First equation becomes equal to 7P2 because that's replacing it with minus P2. Second equation becomes A1 plus 18P1 is equal to 17P2. Now I can subtract these two equations and get rid of A1 because I want to see if there's a relationship between P1 and P2. So if I subtract them, that drops out. 14P1 is equal to 10P2, which means P1 over P2 is 10 over 14 or 5 over 7. Note we're told that they're both prime numbers, so the only solution here is that P1 has to be equal to 5. P2 is equal to 7. Of course, with this ratio, you have multiple values for these two numbers that are possible, but because we're constrained that these need to be prime, the only possibilities are these two. So we know what P1 and P2 are. So we can figure out what A1 is from this equation, or either one. 4 times P1, 7 times 7. So A1 is 49 minus 20, which is 29. And we need to figure out A11, which is A1 plus 10 P1. So that would be 29 plus 10 times P1, which is 5. So that's 29 plus 50 equal to 79. Answer choice C.